We've all been there, right? You're stuck in bumper-to-bumper traffic, and the only thing you can think is, they just need to build more roads. It seems so obvious. But what if that's the wrong answer to a very real problem? What if the future of getting around isn't about pouring more concrete, but about writing smarter code?
So let's really dig into that. Is our go-to solution, these huge, eye-wateringly expensive construction projects, actually the best way to handle congestion? I think you'll find the answer is not what you'd expect.
You see, the key to unlocking this whole thing starts by just reframing the problem. The real innovation here isn't a new kind of asphalt. It's learning to ask a completely different and, frankly, a much better question.
For decades, city planners have been stuck on the question on the left. Where do we build? It's a really slow, capital-heavy way of thinking. But now, with generative AI, we can pivot to a much more powerful question. How can we squeeze more efficiency out of the billions of dollars of infrastructure we already have? It's a total shift from just building more stuff to using our stuff better.
And here's the big aha moment. Most of the time, our roads actually have plenty of space. The gridlock we all hate is usually a temporary problem. You know, rush hour, a big game getting out, a fender bender. It's a problem of timing and behavior, not a permanent lack of lanes.
So the big question is, how much more can we really get out of the roads we already have? Well, get this. We're talking about a potential 15 to 30% increase in capacity. That is massive. It's like getting a brand new highway system for just a tiny fraction of the cost, all by using software to manage our existing network more intelligently.
Okay, so how in the world do we actually unlock all that hidden capacity? Well, the answer is to start treating our road network less like a static piece of engineering and more like a dynamic software-driven system.
Now, before you write a single line of code, you have to have crystal clear goals. The number one goal? Delay or completely avoid spending billions on new construction. We also want to smooth out those crazy traffic peaks and get cars using all the lanes more evenly. But look at the bottom. That's the real foundation. Safety is absolutely 100% non-negotiable.
And here's how it all works, end to end. First, the system just drinks in tons of real-time data. Traffic cameras, GPS, weather, you name it. That data builds a live, up-to-the-second picture of the entire network. Then, a digital twin uses that picture to run simulations. Predictive models look ahead and forecast where traffic jams are about to happen. And then, the star of the show, the GenAI engine. It's the brain, looking at all the possible scenarios and recommending the best move, which then gets pushed out to traffic signals, digital lane signs, or even dynamic pricing.
So let's talk about that brain, the GenAI engine. How does it actually make a decision? Because this isn't some magic black box, it's actually a pretty structured and logical process.
Everything starts with the digital twin. And it's so important to get this. It's not just a pretty 3D map. It is an executable model. Think of it like a perfect video game simulation of your city's traffic. It's a virtual playground where the AI can test thousands of different ideas, like changing light timings or rerouting buses, to see what works best before it changes a single thing in the real world.
And how do you tell the AI what to do? You give it a very clear, very specific prompt, just like this one. You're defining its role. You're an infrastructure optimization agent. You give it a clear goal. Fix this traffic jam without building anything new. And you give it a time limit. Tell me what to do for the next 30 minutes. It's a clear, traceable instruction.
And in return, the AI doesn't just say, try this. It gives you back a structured answer, what we call an output contract. It's super clear. The decision is to optimize existing, the actions are specific, change the green light timing, and give buses priority. It even tells you the estimated capacity gain, confirms that you're avoiding a big spend, and gives you a confidence score. This is data-driven decision-making at its best.
Now, of course, handing over the keys to the city's traffic flow to an AI, that requires a massive amount of trust. So how do you actually build that trust, not just with the city engineers, but with every single person driving on those roads? You build it with rock-solid, non-negotiable safety rules. First off, the GenAI only recommends what to do. It never pushes the button itself. Every recommendation has to pass through hard-coded checks. Things like maximum red light times can never ever be violated. A conflict matrix makes sure it can't suggest something dangerous, like turning left into oncoming traffic. And maybe most importantly, there is always a human in the loop who has the final say and can hit the override switch.
The other critical piece of building trust is proving it works financially. And this system isn't judged by how much it costs to run, but by how much money it saves. The single most important metric is spend avoided. That's the real dollar value of the giant construction projects you didn't have to build because the software made everything run better.
And you can actually put real numbers to this. You measure how much you've cut down on rush hour delays. You track how much more smoothly the lanes are being used, and you translate that directly into how many years you've pushed back the need for new construction. This is exactly how a software system earns its keep in a world that's used to paying for concrete and steel.
So, what's the big takeaway from all of this? GenAI doesn't build roads, it builds something much more valuable, foresight. It lets us see problems coming and solve them with intelligence before we're forced into these decade-long, multi-billion-dollar projects. The cities that win in the future won't be the ones with the most concrete, but the ones with the smartest network. The real question every city has to ask itself now is, are you ready to let software carry the load?